like one step, so then it makes the whole thing easy.
Then yes, I agree. If you make one little mistake, then the whole thing does kind of fall apart. Let's try number 30. This is number 30 on page 241. Multiplying 5b minus 4 quantity squared. I have the parentheses squared, so that means I really have to write it out as 5b minus 4 times another 5b minus 4, multiplying this squared times itself 2 times. If it's squared, it's times itself 2 times. The FOIL process asks us to do first, outside, inside, and last. First times first is this guy. Outside pairing is this guy, the green. Inside pairing is this guy, 4 times 5. And the last pairing, I'll make that black, I guess, will be 4 times 4. A lot of people write those little arches every single time they do it. When I have 2 parentheses, I do repeated distribution. The first thing times both of those, and then the second thing times both of those. First, outside, inside, and then last. First times first, I'm going to write this out so you can look at it later. You would probably do it mentally. Inside pairing, negative 4 times 5b, and the last pairing is negative 4 times negative 4. Again, notice, I just wrote plus, plus, plus in between all of them. I know I have some negative signs. I'm going to change those from maybe from addition to subtraction, but I don't want to think about that right now. I just want to worry about what gets multiplied to what, so that I catch all those pairings, and then as I multiply them, the negatives will kind of take care of themselves. 5b times 5b is 25 for the numbers part, and then b times b is b squared. 5 times negative 4 is negative 20b. Same thing here, negative 20b. And then negative times negative makes that a positive 16. That's a plus. Some like terms I can add together?
20s.
Yeah, the 20s. These, outside and inside, will always be like terms. If these are both of the same type, these will always be like terms. So your O and I should always be able to add together. Plus a negative 40b, or you could say at minus a 40b, whichever you prefer, and then 16.
Does it matter the order?
It's not wrong because addition is commutative, but quite often we start with the variable with the highest power. That's the standard form for polynomials. So variable with the highest power and then in descending order. That's how they'll be on the test, like the answers will be in that order. So it does kind of help you if you put them in that order. Other questions from 241?
Do 70.
Would love to do number 70. More fractions, of course. Let's do that guy. A over 2 plus 4y times a over 2 minus 4y. Tell me one thing you notice about this that seems kind of interesting.
Plus and minus.
One's plus, one's minus, right? In every other way, these two are exactly the same. A over 2 and 4y. And again, a over 2 and 4y. The only difference is one's plus and one's minus. When they look like twins, except one's plus and one's minus, one's adding and one's subtracting, that will always cause the O and the I in the FOIL process to cancel each other out. They'll be the same numbers, but one's positive and one's negative. The O and I will always cancel out when we have similar parentheses, one's addition and one's subtraction, or 1 plus, 1 minus. I'll show you what I mean. Let's work it out. First times first. I don't know, did the arches help? I have a lot of high school kids that still draw these arches, so I don't know if that helps or not, but I know a lot of other people still use them. So. First times first, then first times last. And the blue one is the inside, the second times the first, and then the second, last times last. First times first, a over 2 times a over 2, plus outside pairing, a over 2 times a negative 4y, plus the inside pairing, positive 4y, oops, not 4 over y, first times first, outer, inner, and then last times last. In these two, again, multiplying fractions, that's no problem. Top times top and bottom times bottom. So I take a times a and get a squared. 2 times 2 is 4. So first times first gives me a squared over 4. Plus, these two, it might help me to think of this as over 1 because this is a fraction. So if you want to, you can write this as over 1. And then you have top times top, which gives you a negative 4a times y over 2 times 1, which is 2. Plus, same thing here, maybe think about that as over 1, and then you get 4ay over 2 times 1, which is 2. Aha! Negative, blah, 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 and then positive, same thing, right? So, I'm skipping ahead here, but these two, one's plus, one's minus, but they're both equally ugly, they're going to cancel each other out. They'll always add to 0. 4y and a negative 4y is negative 16y squared. So, what we've seen here is that this and this are additive inverses or opposites of each other. They cancel each other out. Then I have a squared over 4 plus a negative, or just minus, 16y squared. In this section of special products, this is the most important type, because you really can save yourself a lot of time if you recognize these quickly. When the parentheses match, but one is addition and one is subtraction, when I multiply this out, the inside and outside always cancel out, so I'm left with just the f, first times first, and just the last, L times L. Well, first times first is just squaring this guy, right? Last times last is just squaring this guy. So when you look at this, if I square this, that's what I get. If I square this, that's what I get. Of course, this is negative because I'm multiplying a positive times a negative. So I have a minus, and then this thing squared. So when you see, when we factor in the next section, or next chapter, I'm going to look at this and say, how do I break it back down to the parentheses that were multiplied together to get this? That's doing it backwards, FOIL in reverse. And this is so easy if you recognize that it's something squared minus something squared. So I know it has no O and I, no middle two. So if there's no middle two, it has to have come from something like this. Twins, where one's addition and one's subtraction.